there's anyone here that has experienced unusual or disruptive weather and had to make a decision or help make decisions in those moments, this lightning talk is for you. My name is Tim Loftus and I manage the data science team at AccuWeather. I'm here to present how you can turn weather risks into opportunities by utilizing our weather data available on the Databricks Marketplace. I'm fortunate enough to work for and represent a company whose mission is to save lives, protect property, and help people and businesses prosper by providing superior weather data and expertise that you can take advantage of to help make you more informed decisions. In an era dominated by powerful tools and algorithms, we make data human with our unparalleled domain expertise, our 24/7 support and global reach, easy data access, and a long-standing history. The first commercial weather company that's become the most used source of weather in the world. We have experts in all domains like air quality monitoring, severe weather warnings, long-range forecasts, and weather-related risk management, to name a few. And we are everywhere. We provide diverse access points to make it easy for you to stay informed, wherever you may be, and through a medium that suits you the best, whether it's our internationally recognized mobile app, or AccuWeather.com, or news and media and TV and radio, or other platforms. And the underlying data that supports these platforms, we've now exposed through the Databricks Marketplace. Our AccuWeather Data Suite includes over 30 years of historical weather information, and we also have current conditions or near real-time weather information, as well as forecast data extending up to 90 days. And this will enable you to understand unique weather relationships against your own business metrics. And at last year's conference, we were here and presented and demonstrated common patterns of use of our weather data to showcase its potential and help inspire you to apply it within Databricks using cutting-edge tools and data science techniques. And I'll highlight these for you now. On the top left, you can see our weather data in use in enhancing demand planning by predicting changes in consumer behavior, such as solar energy demand, using parameters like solar irradiance, precipitation, degree days, wind speed, among others. On the bottom left, we show that you can enable weather-targeted advertisements and marketing campaign strategies, tailoring those campaigns to increase relevance and engagement, like this now award-winning Feels Like Spring campaign that we supported with Lowe's to help reallocate in their spring merchandise ahead of when it feels like spring. And additionally, it also provides situational awareness through a BI dashboard on the top right for proactive decision-making and resource allocation, visualizing forecasted weather against AccuWeather climate normals to signal above and below average conditions, protecting your employees and assets, as this example shows. And now I'll provide yet another use of our data and what I'm an expert in weather data intelligence and risk management. So what is weather risk? It refers to the potential adverse effects or uncertainties caused by weather events on people, properties, and businesses. In its simplest formula, it is the likelihood of an event compounded by the impact or costs that event had at the time and location of interest. And my hope for this presentation and lightning talk is to show you how we at AccuWeather developed a patented machine learning workflow within Databricks that can help users break down that risk formula and apply it to your own needs. For example, retailers lose money by overstocking. And when overstock occurs, it means you're paying more for shipping and storage and labor. And if sales don't cover costs or production and handling and transportation, then the business will lose money. And this will definitely occur on peak business days like the weekends for a home improvement retailer selling grills in the summer. By leveraging our enriched historical weather data, you can use this information to derive weather relevance at your location and combine them with your own business metrics to begin modeling what, when, and where the highest weather risk to your business is occurring. And we'll take that information and put it into a digestible format to make it easy for you to understand, taking the complexity out of complicated weather forecasts into a simple AccuWeather impact indicator from minor to extreme impacts using our predicted or forecasted weather data. And this process can be a template for you and be applied to predict service disruptions or spikes in insurance claims, field worker injuries, or potential revenue losses, among others. And we'll do a demonstration here showing that process to you now. So within this notebook, we're gonna, again, break down that risk formula into two different parts. The likelihood of the impact, which will come in the format of our weather data, and the impact or the cost, which we hope to collaborate with businesses where you can bring your own data into this process. And we'll leverage not only your data, but your expertise. So walking through this notebook, as part of any analysis, we have to get our notebook ready. So we'll install the packages needed and imports and begin data exploration. For this notebook, we're gonna account for alcohol sales loss as our business impact data and marry that with our AccuWeather historical data to calculate that likelihood of occurrence. So the first part of this analysis is some initial exploration of our data, querying certain risk factors that we're going to account for and hypothesize around what could contribute to alcohol sales loss. In this case, we're going to target heat and cold and precipitation, snow and wind. And we're going to take advantage of those exclusive parameters that only AccuWeather offers, like our proprietary AccuWeather real field temperature, a great indicator to signal how it really feels to be outside. We're going to aggregate this data by state and week to match our business data that we're going to pull in later. And you can get a sense of the distribution of our data through these really cool visualization widgets in these commands. So this is showing, again, maximum real field temperature across each state that we're working with. The other awesome tool that Databricks offers is the data profile. So it really helps quickly absorb and understand the shape and content of our data to prep for our analysis. Once our data and our data frame is pulled in and queried and it looks okay and ready for our model, then we can begin to calculate recurrence intervals. How many here have heard of a 1,000-year event or a 100-year snow event? Okay, some statistical meteorologists in the house, so good to see. That is called a recurrence interval. We're going to use these recurrence intervals to calculate probabilities, probability of exceedance, or the rarity of event. If you're not accounting for the rarity of an event at your location, you lose out in uncovering weather risk. 2 inches of snow in Atlanta is going to have a different impact than 2 inches of snow in Boston or Denver. So we can use that intelligence as a part of our risk model. We're going to apply that probability of exceedance and derive probabilities and observe those in this command here. So again, just to look at the output, we can see our probability of wind and then the impacts of wind. And if I sort that, you can kind of see the changes between a very rare or a rare event. Looking at this in plots, we can account for, again, the differences in space. So here I've selected 4 states, Texas, California, New York, and Colorado. In Colorado, shown in green, the threshold for minimum real field temperature of their extreme is negative 59 degrees Fahrenheit. But in California here, it's negative 18 degrees Fahrenheit. So again, if you're not accounting for this tail risk and capturing that tail risk, you're not capturing any of the events that could pose the most impact to your business. Classifying that data as shown here by cold impacts by state. Now we're capturing and classifying that tail risk or the ends of that probability distribution from very rare to extremely common. I have classification columns that I'm going to use to help as training features in a model. So we'll get there in a second, but this is the next section here of this notebook is where you come in with your business data. So I, as a data scientist, want to not only capture your information, but your expertise too. You know your business the best. So you might have business rules around what is deemed high alcohol sales loss. And working with a said alcohol retailer, we can reclassify their information. And in this example, we pull in data from the USDA that has product sales information at a weekly level, and we're gonna compute a sales loss parameter and classify that from minimal to high impacts based on their business insights and rules. Now we have a business data frame and a historical probability or risk data frame with our classifiers. We're ready for model building. To prepare for our training, Databricks has a lot of enriched tools within MLflow, their open source ML framework. I personally love pipelines. It's a quick and easy way to modularize your code and reproduce. In this example, I'm doing some data preprocessing. I'm taking advantage of the string indexer and the one-hot encoder to convert and prep my classifiers into a usable format for my machine learning algorithm. Now that I have that prepped and ready as a trained data frame, I can do some initial exploring of the relationship between impact of sales loss and my risk factors. Through a correlation metrics, you can see the highest correlated or related risk factor is heat. It has a positive relationship, meaning that the more extreme heat, the more loss in alcohol sales. Maybe people are switching to water, probably a good idea. Oppositely, for snow and wind and cold, a negative relationship, meaning people are stocking up when things are cold and there's some wintry weather coming. Makes sense for me so far, but correlation's not causation, so we're gonna do some additional testing here. With working with weather data, I always encourage our users to test for multicollinearity. Weather is highly interdependent, so throwing this into a quick test here, you can see my highest factors have all variance inflation factors below 2, so that's a good signal that it's okay to proceed here with our model training. And let's begin our baseline model, taking advantage again of MLflow capabilities. I'm gonna set my experiment, call it impact experiment, and select my features and label column for the model. I'm gonna use a random forest classifier, but as a data scientist, you should explore other models. You don't have to choose a random forest classifier. Depending on your data, maybe a support vector machine learning model is the best, or a decision tree. And within Databricks, we are allowed to do that experimentation. That's the fun part. So in this example here, we're gonna use a random forest classifier. I'm gonna also set up my signature, the input schema and output schema of my model to help for future deployment if I wanna push this further. Once the signature is set and declared, I'm ready for logging. I'm using MLflow start run. I'm gonna name this model the random forest classifier, set up some log parameters of some of my tuning parameters like number of trees or max depth. I can also set up my performance indicator, in this case, the area under the curve and my evaluation here. I did add some additional logic here to account for the different classes. So we have high, moderate, low, and minimal. I can score each of those classes within this command here. And once I log the model, I can print out the accuracy for this proof of concept. With weekly state level data, we got, just with 4 risk factors, we got an accuracy of over 80%. So a pretty decent model for us for this purpose and demonstration. But once I have this experiment logged, I can always go in and to look at other experiments that I've tracked. I love this charting tool here to kind of account for all of the different experiments to see how each one performed. Really seamless and cool visualizations to kind of target areas of improvement for my model. And you can see the overall model for most of these achieved over 80%. Going back into the notebook here, we did it. We got a model logged and ready to go. I want to just run some feature importance, and we can see that heat is the most predominant, highly important variable in this model. And now I want to register it into Unity Catalog. Databricks offers really quick tools for us to prep for registration of our model and deployment. I'm setting my schema, our demo schema here. I'm also naming my model output, ML flow, RF impact here. You can check the status of the model, whether it's ready or not. You could also select its version and set its version and model description. You can add tags. Going into this Catalogs Explorer, once I have that set up, really easy for us to see what model versions exist in Unity Catalog and being able to see which one's our champion model that we want to push to production and get ready for our alcohol retailer to absorb. Again, as mentioned before, in this notebook, we're going to use another decision tree to begin a new experiment. Have fun with this. You can test and experiment multiple models. Again, this is all using a classifier model. We're using a decision tree, printing out the same stats here. Our area under the curve, a little bit better, 81%. One of my favorite functions in MLflow is search runs, being able to print out what the best run is of your model. In this case, 82.5%. So the highest model we would want to push to possibly production state there. The best part of any is to see the results, right? So here at the end, I'm going to hit play just to show you what this model is going to do. Again, accounting for spatial relevance and being able to know where and when the most risky weather is occurring based on alcohol sales loss, ranging, again, taking your business insights and data and making it more digestible and understandable for you to absorb. So weather data intelligence for all there. So we know the weather, but you know your business more. So let's work together and collaborate and utilize AccuWeather data available through Delta Shares on the Databricks Marketplace today and utilize their incredible MLflow tools and capabilities to help predict weather risk. This is a look at our data suite. As mentioned before, we have historical, current conditions, and forecast weather globally available for you and ready for analysis. Here's a quick look at the AccuWeather Data Suite. And in terms of our packages and global coverage, it's global. We have over 160 historical weather parameters and over 90 forecast parameters. We also have our own climate normals data sets that we can also share through Delta Shares for any location that you may want. So let us help you during those stressful and uncertain decision-making moments when disruptive weather occurs. Come meet us at our booth. We're over there at the Partner Hub and Marketplace and talk weather. We would love to meet you. We have an incredible team here representing AccuWeather. And also please enjoy our booth and our swag and come to check out more demos if you'd like. We also have another talk with Dr. Tan tomorrow from the Children's Hospital of Los Angeles. So please join him as well for his lightning talk tomorrow at 11 a.m. Thank you.